I'm Dave Darrah. I've been the QE lead in the container runtimes group at Red Hat for about 9 years. Just in the last couple of weeks, I've taken on the role of product owner in that group. So if anybody knows what that actually entails, please tell me. So basically, the things I want to talk about today, it's Podman beyond the command line. I know a lot of people here are Linux administrators. They're probably using Podman, Docker, and on the CLI, and I did say the Docker word. But these projects we've been looking to just reduce friction for adopting and developing container technologies, and also to use containers more on a system basis as opposed to a cluster basis to do things like services and system operations that we as we get to more and more immutable operating systems, you wouldn't want it makes it a lot easier to install things and run them on a system without contaminating the system. So the first thing I want to talk about is Podman Desktop, which is a project that's been going on for a while, and we'd like to say containers are Linux. We put it on T-shirts, we gave it out and everything, but developers work everywhere, and you'll see that with the number of presentations that are being done on Macs today, that's a very popular thing to work on. So we're doing a macOS, the Podman Desktop team, Windows using WSL, gives you a visual management for the stuff. You can install it in a minute, and I got a recorded demo that'll basically run you through that'll play in a little bit. Gives you visual monitoring on resources and reduces the learning curve because it gives you wizards to fill in what you need and suggestions for things like that. And it also supports plugins to do extended things like clusters and things like that. You can actually do pods, Minikube, and things like that. So the basic functionality is container management. A lot of these things are the same. You get shell access, you get the container operations for start, all that stuff. Monitoring, you can manage your images directly in the UI, and you can create pods and export or work on those and develop them. There's also some Kubernetes integration. You can have local plugins for clusters on your system, allow you to do development of pods before you have to spin up an entire cluster or put it out on a public cloud. And you can develop your pod and then push it directly from the tool to where you want to go. And like I said, there's a lot of extensions. We've put a Podman AI extension in there. You can do AI applications. It's got a lot of stuff that allows you to do that. Models and utilize them in containers. There's some Red Hat specific containers for OpenShift and some of the enterprise stuff. There's Bootsy extensions, so if you want to use image mode, you want to build your own images for operating systems, you can do that. And it's an open extension system, it's an open source project, so if there's another application you're looking for, you can write your own. Slides are going. All right, nice. So this was a video of installing it on a Mac, which is not loading at all anymore. But essentially, you go to the web page, you click the button, it gives it to you. It will automatically create the VM in the back end, because on macOS and on Windows, you were using their virtualization. libkrun is our version now for Mac, but they have their own shell as well. The performance isn't as good. And then WSL, I have no experience with. Oh, here we go. But let's see if this works. Yeah. So this workflow, for anybody, you go, it detects what operating system you're on already, installs it. It's Mac OS, So you have to fight with macOS to allow you to install things that don't come from their application, but we'll ignore that. So please run the application I told you to. It really is as simple as dragging that into the applications folder and then running it in the applications folder. Although macOS is going to nag me again because it doesn't like that they didn't sell me this product. Yes, please run my thing. It brings you right up into the dashboard, gives you a wizard to set everything up, including, this is the Podman configuration, which doesn't really entail anything. And then it's going to tell you don't have a machine. It's going to allow you to configure the resources on the machine, kick it off, and tell it whether or not to launch it every time you launch the desktop. And you're up and running. The real point of this is you really don't even have to know anything about containers to get started. You don't even have to really know anything about Linux. That's my video buffering, not the install. So yeah, now you're up. I'm going to click through a couple things, but I'll talk about there. You can manage your registries. You can look at dashboards there to tell you how many resources your machine are using, or individual pods, or individual containers. There's a lot of logging you can look at for a container and pod. There is CLI that give you a shell to interact with the running containers. It comes with a couple of the modules installed already, and you can install other ones from inside the tool. All right, this is way too slow, so I'm just going to move on from that. Really, all I was going to do is open up the wizards and start a container, which is exactly what you're looking for. All right, so the other thing I want to talk about is systemd generate. A lot of the container excitement in the industry is around cloud apps and cluster apps in things like OpenShift, Kubernetes. But they're a great model, and we've kind of been doing this since the Atomic Host days at Red Hat, where you can run systemd or system processes as a container. And the systemd generate, I'll be honest, the kubelet, it frustrates even Podman developers sometimes to get everything running the way it's supposed to. But you create your container files, you create your pod file, you put them in the right place, and when you daemon reload systemd on the Linux system, it will auto-generate your service file for you and allow you to start all those containers using systemd's management. So upgrades, dependencies, run on boot, things like that. Those all come for free with systemd. And also the health check portion of Podman is supported there too. So I mean, it's like every other cluster type things. The kubelet is declarative. You define your containers, volumes, networks that you want available. The service is created automatically and ephemerally, so as things update, it will update the service every time the daemon reloads or you reboot. The simplified management is at the systemd level. You can make sure that it only loads when things are supposed to be loading. Enhanced dependencies, once again, loads things in the right order, and you can apply resource constraints or load rules there that depend on other things. So the systemd unit files, they're not. You can't actually do anything with them because they're not present on the file system. But you can generate unit files that are dependent on each other. So there's a strong caveat with this because most of the examples that I've done have been rootless services. You run them as a user. But systemd will only run a user service if you are logged in, unless you use login control to tell systemd that you linger. And like, people nodding their heads have probably spent the time figuring that out because it's not obvious and it's very frustrating when you're trying to, why is my systemd unit not loading? That command is almost 90% of it, so I thought I wanted to call it out here. If you haven't done this before and you try it, you'll eventually, this will occur to you, hopefully. So your container files are just like a systemd unit, but with a container section. You tell it what pod it needs to be in, you give it a name, you tell it what actual fully qualified container name you need. I'm doing a pod basically that does nothing because it's going to be a pause container running with another pause container in the cluster. And then you define your pod files. And here's where you can do your dependencies for systemd manager. Like this pod wouldn't, this pod needs the network, so it waits for that service. It also needs the Podman auto update service or timer, and then the application containers is necessary there. This is also where you publish anything pod wide, like ports and things like that, and what target on the system needs it for systemd. And then it generates full unit files from that. I'm not going to go through all this. This is for the container. There's another one for the pod that's even longer. But because systemd handles all that, you don't have to worry about any of the syntax in there. On top of that, we have Ansible integration, 2 minutes, which allows you to, Ansible has included modules that will allow you to use Ansible to configure these things so that they can be applied across systems consistently with the declarative language of the YAML files. There's a demonstration a guy named Michael Fox did at Southeast Linux Fest this year with Podman and Quadlet and Ansible rootless service. It's a full hour long. He does a lot of good examples and a lot of, it's worth checking out on YouTube if you have a chance. But the Podman stuff, systemd stuff comes by default with Ansible, and you can call them in the, now I'm blanking on what the included libraries are, the path there. This is running. It's going to start over in a second. So basically, this is just an example of how you, there's my pod. Boy, these sleeps seem shorter when I was doing it. All right, so I've got an HTTP YAML that's defining what is going to go into this pod, pointing to those files in the path. And basically, I have a playbook that is going to take those pods, take those files, copy them into the right place, and then just do a daemon reload and wait for the system to come up, for the services to come up. This can obviously be integrated into any of your automation for configuring and provisioning your system and allow you to push containerized stuff all over the network. So yeah, your pod's up. I've got 2 pods containers running, which is groundbreaking. You can also take these pods that you develop, use Podman kube generate, and basically capture all the cluster stuff. Here's the pod that I just created with those 2 containers, and the last thing, you do a kube generate, and now you've got an exportable one. This is the same mechanism that's going to be used in the desktop portion of it. And I have 12 seconds. And I knew I wouldn't get to it. There's going to be a talk tomorrow about Healthchecks and containers by Mohan's doing that, right? Mohan Badu? Yeah. Matt's going to do it? All right, so tomorrow there's a full hour.